Let us start lecture 50. The course is on phase diagrams in single component and binary systems. Today's topic the enthalpy of mixing and Gibbs free energy of mixing, and we will see their behavior when we deviate from ideality. In the last lecture, what we have seen, we have considered a couple of things which are important. One is definitely when we talk about partial molar Gibbs free energy of mixing of a particular component, then we see that when we go to a pure metal side or a very dilute solution, we see that the solute mixing Gibbs free energy or the partial quantity of that solute would be minus infinity. Okay. At the same time, we have also seen 4 cases. The case 1, 2, 3, they are considered in such a fashion that the Gibbs free energy of mixing, and if I plot it with mole fraction which is x b, we see that all 3 cases the plot becomes symmetric as well as convex downward. And we have seen that the stability of with the help of stability or the free energy lowering, we have seen that any composition you take over the entire composition belt from A to B, pure A to B, there would be always a downward a single homogeneous downward movement of Gibbs free energy, okay, and that movement would allow a single phase solution formation. Okay. So, now case 4 will start. The case 4 talks about a situation where alpha is having very large value, consecutively del H mix will have a very large value, and there will be a situation that delta H mix at a particular situation, there could be a portion of the composition range, the free energy or the Gibbs free energy of mixing plot with composition can take a shape upward, okay, instead of all the time downward. So, we will consider that part today. So, let me just see what we have seen in the last lecture. So, we are of course considering binary solution, considering 2 metals A B, X A and X B are basically the mole fraction of those 2 metals, and this is 1 mole, and we are talking about at a particular temperature pressure is 1 atmosphere, we are creating solution and we are applying a regular solution model. All the assumptions related to regular solution model will be applicable here. Fine. First of all, what we have seen, we tried to plot this is 0, this is 0. This is delta Gmix plot with respect to x b, and we have also seen that any point over this particular curve, if I draw a tangent, that tangent will give me the values of delta G m b and here delta G bar m a, this is this quantity, and here delta G mix, that is the plotted here, and this side is pure B, x b equal to 1, and here pure A, x a equal to 1. So, this is the situation, fine. And in fact, we have seen that this becomes R T ln A B, x b tends to 0, A B tends to 0. So, that suggests that delta G, so this goes to minus infinity, fine. So, in fact, that time we have to consider at this location, fine. So, this location applies to this. And when we talk about this one, which is RT ln A, that goes to minus infinity when x a tends to 0, a tends to 0. So, that time that point corresponds to this. So, this is that point. Why? Because we have to draw so for example, if we keep moving like this, so we will reach a situation of x b tends to 0. So, at every point we can draw a tangent like this. So, finally, we will have a tangent here, which will be vertical downward. Okay. Similar situation appear here. So, we will keep drawing tangent at different points. So, x a would turn out to be 0 as we approach P or B side. And we have also seen a situation that if I take a composition here and another composition, let us say composition here and composition here. So, if I try to see these two solutions are mixed together. So, this is the free energy, let us say G mix, it is not mix, G unmixed of two solution. Let us say this is A solution and this is B solution of A and B. So, now when we mix them, we will see always, and if we take equal weight fractions of A solution and B solution, there would be a point C and that would go to the minimum value D. So, we will see that there is a free energy lowering. So, even if you start two compositions, two solutions with two different compositions, they will, when we mix them together, it will be a spontaneous mixing and we will achieve one single composition solution. Fine. These two things are learnt, and when we try to see this, for example, case 1, what are those cases? Case 1 is delta Hmix equal to 0, alpha equal to 0. Case 2, delta Hmix less than 0, alpha would be less than 0. Case 3, delta Hmix is slightly positive, alpha is slightly positive. Fine. So, these all three cases we have discussed, and we have seen that the Gibbs free energy plot, which is delta Gmix plot, is convex downward. Okay. So, delta Gmix versus x b, that plot is convex downward. Fine. But case 4 where delta Hmix having very large value, or we can actually see how if we keep changing alpha, of course, greater than 0, and if we take it to a very large value, at a particular temperature and pressure, these are constant. So, if we keep changing that alpha value, it means that we are changing this interaction value. Let us say we have that freedom of changing that omega value. Then what will be the influence on delta Gmix plot? So, when that is the case, what will be the influence on delta Gmix or delta Gmix by RT plot with XB. So, this question we would like to address in today's lecture. So, now we just write down the expression when we talk about delta Hmix greater than 0 as well as equal to 0. So, now there are two conditions, one is ideal, another one is non-ideal. Delta Hmix by RT equal to omega XA XB equal to RT alpha XA XB. So, I can write delta Hmix by RT alpha XA XB, delta Gmix equal to delta Hmix minus T del S mix. So, this del S mix for ideal as well as non-ideal both cases will be same. So, del S mix. So, I can write this one as RT alpha XA XB plus RT XA ln XA plus XB ln XB. So, we can write delta Gmix by RT equal to alpha XA XB plus XA ln XA plus XB ln XB. So, this is the non-ideal part, and the ideal part del H mix equal to 0 means alpha equal to 0, and we will take a condition alpha is greater than 0 and it varies starting with the lower value to a higher value, and here delta Gmix is equal to RT XA ln XA plus XB ln XB. So, I can write delta Gmix by RT. So, in order to differentiate I can put a small ID here, this is ideal XA ln XA plus XB ln XB, and remember both cases del S mix equal to minus R XA ln XA plus XB ln XB with a bracket. Okay. Both cases it applies. So, now we will start plotting this one and this one with respect to alpha values when alpha takes positive values at a particular temperature and pressure. So, let us see that. So, this is 0, here on this side XB equal to 1, this side XA equal to 1, 2 pure side, and let me change this way. Now, when we talk about ideal, so ideal case alpha equal to 0. So, let me plot the ideal one. So, this is delta Gmix by RT when alpha equal to 0, and it is nothing but ideal. I can push it little downwards, then only I will be able to put other free energy curves. Okay. So, this is that. Now, I draw the del H mix by RT. So, let us say this one is, this is delta H mix by RT when alpha equal to 0.5. Remember, this is also nothing but minus T del S mix. So, when we try to look at the delta G mix value when alpha equal to plus 0.5, then it is nothing but the combination of this quantity and this quantity, okay? Because that this quantity is coming here, which is this is also to be divided by R t. So, this is nothing but minus T del S mix by R t. Okay. Now, if it is that, then the del G mix by R t when alpha equal to 0.5, it will move upward actually. Still it will be convex downward, because if I consider, and both the plots delta G H mix by R t and delta G mix I d by R t, both these plots are symmetric over the composition range. In fact, if we try to look at the peak value, so this will be peak value which is 0.5, here also this is peak value which is 0.5 of x b. Okay. So, now if I try to look at that length, so if I try to see the length from here to there, that length is, so this length if we consider, that length is much bigger, that the delta G mix I d by R t is having much higher negative value compared to the positive value of del H mix by R t at x b equal to 0.5. Okay. So, that means the curve, the resultant curve would be still, so the resultant curve would be fine. So, this is my delta G mix by R t alpha equal to 0.5. Now, I keep increasing the alpha value. Let us say I go to alpha equal to 1. So, this is delta G H mix by R t when alpha equal to 1.0. I could see even alpha equal to 1.0, I still see that the value corresponding to alpha equal to 0 for that delta G mix I d by R t still very high. So, I can actually check the curve, that curve will still be convex downward. Okay. So, this is, so this plot is nothing but delta G mix by R t when alpha equal to 1.0. Now, I could see that as we increase the alpha value, the delta G mix by R t, that particular curve still becomes convex downward, but it is moving up. Now, I take a situation of alpha equal to 1.5. Let us say this is delta H mix by R t when alpha equal to 1.5. Now, I could see that that value is, that midpoint del H mix by R t value is coming closer and closer to delta G mix I d by R t or minus T del S mix by R t. So, we have a situation like this. So, the plot would be that delta G mix will still be up convex downward, but it will be further up. Fine. Now, let me increase. So, this is delta Gmix by RT when alpha equal to 1.5. Now, I increase it to 2.0. So, when I take it to 2.0, so let me remove this thing so that I can extend that curve. So, this is delta Hmix by RT alpha equal to 2.0. Now, I see that midpoint values of delta Hmix RT and delta Gmix by RT, those two values, of course, they are, one is positive, one is negative, they are coming very close, actually almost similar to each other. So, then I can have a situation, but still little less than this value is little less than this value. So, I can have a plot like this. Now, I can take a different color. Okay. Now, I increase this delta Hmix by RT little farther. So, I can take it like this. So, let us say this is delta Hmix by RT when alpha equal to, let us say 3.0. Now, I see that alpha when it is 3.0, this value at midpoint, which is 0.5 of xp, is actually more than the mod value of delta Gmix by RT at 3.0. So, this one, so I have not marked it. So, this one was delta Gmix by RT when alpha equal to 2.0. Now, when it is 3.0, since we are starting with 0 point, so the curve will gradually, so let me do it with a red color. So, this midpoint delta Gmix RT by RT at alpha equal to 3.0, around midpoint of composition, it will be actually more than the 0 value. So, the plot would be like this, Okay. So, I have drawn it with it will be symmetric. Okay. So, that red one, the red one is delta Gmix by RT alpha equal to 3.0. In fact, had we taken another which is in between 3.0 and 2.0. So, let us take that. So, that will make things little better. So, this is another value what we are taking. So, let us say this is delta Hmix by RT alpha equal to 2.5. So, this plot would look like this. Fine. So, this is that plot. So, let me do it with pink color. So, this is delta Gmix by RT when alpha equal to 2.5. Now, interestingly, we could see that as the alpha value is increasing at a particular temperature, we see that the delta Gmix by RT plot initially at a lower value of alpha, the curve was convex downward, but around alpha equal to 2.0, that curve, the delta Gmix by RT plot around that mid composition values, it is actually getting flattening up. But as we increase the alpha further, then we could see that the extreme ends, that pure metal ends, there is a plot which is convex downward, but midpoint we have convex upward. As we increase it further, that means that alpha is increased to 3.0, even 2.5 to 3.0, we see that that delta G mix by RT plot is having two segments, rather three segments, starting with let us say a pure B side. First it takes a convex downward, then at around some point it takes convex upward, and then again around some point it will be further convex downward as we reach closer to pure B. Now, question is, this shape is coming by the combination of these two del H mix by RT plus del G mix plus this particular term, Okay. So, this particular term, fine, these two values are added together. So, the shape of delta G mix by RT is changing, but that change is extremely critical from the stability of phases. So, that stability of phases, when we have such typical shape of free energy of mixing plot, okay, with composition. So, that will be discussed in the next lecture, but we have to answer to that point that let us say that delta G mix RT by RT is extremely positive. So, very high. So, let us say it becomes like this, So, can there be, this is let us say delta G mix, delta H mix by RT alpha equal to let us say 5.0, but we will still see that plot of that would be like this. Still there would be a convex downward portion, though that zone will shrink. Okay. So, that convex downward portion, so this particular line is talking about delta G mix by RT when alpha equal to 5.0. Still there will be a small section on the extreme two sides, pure metal sides A and B, there will be a convex downward pattern of delta G mix by RT with composition if we plot. Okay. So, now question is, can there be a chance that over the entire composition range delta G mix by RT, that plot, when a situation arises like delta G H mix is extremely positive value, very high positive value, can there be a chance that delta G mix by RT would be always convex upward over the entire composition range? So, we have to answer that part. So, that part is interesting, because that suggests one important aspects, that why can we not have a pure metal ever. Okay. So, that part also will be discussed in the next class. Okay. But at least we know that how the shape of delta G mix by RT, or other way around, now we can also reflect in terms of delta G mix with composition plot, when delta H mix is taking very large value, is taking its shapes, is modifying its shapes, and that modification is like this. So, if I try to plot only the delta G mix plot, this is pure metal sides, x b equal to 1, x a equal to 1. So, the plot looks like this. Okay. This is delta G mix plot with x b, fine. So, it is taking such typical shape. So, at least that part we have understood, and that can arise when delta Hmix is very high value. But those two questions, what will be the stability of solution as well as why even at a very high value of del Hmix, still the curve is not taking shapes like this. So, this curve will this curve will never be like this. This is delta Gmix, let us say this is a plot. So, all throughout this is a never possibility, it can never happen. There will be always a tiny section, there will be always a tiny section, it is moved like this, there will be always a tiny section which will be convex downward at the extreme end. So, that part also we would like to respond in our or discuss in our next lecture. Thank you very much.